Hi, so I decided to show number 13 a little bit differently. Again, this is page 156, the book test for Unit 4. So this is a great practice, and number 13 is actually pretty tricky. So if we just look at it as the question, you can see that there's a couple things going on to the variable b that we're going to have to undo to isolate the variable b. So first off, you've got that 4/7 in front, and that 4/7 is positive because it has no sign. So to get rid of that, you know we're going to subtract 4/7 on both sides. So that's not really a problem. You got negative 1/7 and then subtracting 4/7. They're both negative terms, so you can use same add keep and you get negative 5/7. But I started getting a little bit too big with my writing. I'm going to make this a little smaller. We still need to bring down this entire term. Remember that if you have a negative variable, negative b, that really means negative 1b, this invisible coefficient. If it doesn't have a number in front of the variable, it's really a 1. And whenever there's a negative sign, you really have to make sure that you're careful with that. So I'm going to bring down negative 1b. Now the inverse of multiplying by negative 1 is to divide by negative 1. So you can divide by negative 1 on both sides. This looks a little bit funny. You could multiply by the reciprocal of negative 1, but it's still going to be negative 1. So I'm just going to show it, and you just have to deal with the way that it looks. You know that any number divided by 1 is going to be the same number, but now really the game that you have to play and the thing you have to watch for are the negatives. So you see two negatives means now the answer is going to be a positive. So this is now positive 5/7. But let's make sure that we watched our sign. We had the same sign here, but remember what happens when we divide by a negative on both sides. This is where the sign is going to twist around, and it's going to become the opposite. So the final answer is b is less than or equal to positive 5/7. So we're going to graph that, put the positive 5/7 in the middle. I can see that it's got the crayon, so that means we have a filled in circle. What I mean again is this extra line right here means that 5/7 is included in the answer, so 5/7 could be a part of what b is, so it gets filled in. Next, b is less than or equal to 5/7. So again, these are a positive 5/7, so less than 5 would be 4, less than 4 would be 3, and then on this side you'd have 6 and 7. And then very easily you can just cruise on by and put them all over 7. Now, b is less or worse than 5/7. So that would mean 4/7 and 3/7. But also let's just really look at where the variable is. It's on the left. That means this inequality, this direction that's pointing to the left, is the side that we will shade. So this matches this when the variable is on the left. And you just color it in. All right, next we're going to go back to our wonderful student Jose's paper. Number 14 is here. All right, that's the score coming through the paper, so let's just go like that. Okay, number 14. First off, he did a great job using the distributive property. Negative 0.3 times d is negative 0.3d. Negative 0.3 times positive 6 is going to be negative 1.8. So there's two things happening to the variable d. They're multiplying by negative 0.3 and they're subtracting 1.8. So we always undo addition and subtraction first. So to get rid of that negative 1.8 or subtracting 1.8, we're going to do the inverse operation. We'll add 1.8 on both sides. Now, this looks like we need to double check our math. This is a negative term. This is a positive term. So this is going to be different, subtract, bigger. So really, we're going to be thinking 1.8 minus 0.6. So this is going to be 1.2. Now let's look at the sign that we need to keep, because we're doing different, subtract, bigger. The bigger term here was positive, so we're going to bring down the positive sign. So it's positive 1.2 is less than, no, sorry, greater than negative 0.3d. Now you're going to divide by a negative on both sides. So again, this is where you've got the negative as the coefficient of the d. To get rid of multiplying by negative 3, you do the inverse operation. You divide by negative 3 on both sides. But remember, too much negativity down in the multiplying and dividing area, deep down, underneath the frosting area, deep down, too much negativity will change you. So always make sure you're around good friends, good people. But in this case, it means the inequality is going to switch from greater than to less than. Now let's do the math. 8 won't quite be the right answer. You guys, of course, are going to be redoing the problem on the side in pen and doing a highlight box around it so you can really draw your attention to when you're learning from your mistakes as a part of your growth mindset. Okay, so this is 1.2 divided by 3. If you have trouble with that, remember you're going to move both the decimals one time. If you wanted to see what that work would look like, this is in and out. Remember with the fraction bar, it's still in and out. If it was horizontal, it would be in and out, but it's stacked, so it's in and out. So you're going to put the 1.2 on the inside, 0.3 on the outside. Both of them, you need to move the decimal one time to make them into whole numbers, and then straight up. So this is really 3 into 12, which will go 4 times. So the answer here is 4. Now you're going to verify and make sure you have your right number of decimals and your decimal rules are being followed. A positive divided by a negative, in other words, one negative in the question, means the answer is going to be negative. So we're going to put negative 4 in the middle. Negative 4 is here. I don't see the crayon, so it's going to be an open circle. Worse than owing $4 would be owing 5 and owing 6. Remember, to the left, numbers are less when you go to the left. Or worse, like owing 5 is worse than owing 4. Owing 6 is worse than owing 5. And they would be better when you go to the right, better or greater. Now this says negative 4 is less than what D is. So if you're thinking about the hungry mouth choosing the best thing, D has got to be better than owing $4. So better than owing $4 would be owing $3 or owing $2. Reminder of our quick way to double check. If the variable is on the opposite side, if it's on the right, then the sign is going to be the opposite. So it was pointing this way, so that means we shade this way. That's the truth. When the variable is on the left, the sign is correct. When the variable is on the right, the sign is wrong. Okay, number 15. Number 15 gives you a lovely word problem. It says you have $2.50. Each sugar-free gumball in a gumball machine costs 25 cents. Write and solve an inequality that represents the number of gumballs you can buy. Okay, so Jose said 0.25G is less than or equal to $2.50. Then we needed to solve it, so we're going to divide by the coefficient of G, the 0.25 on both sides, and you're going to get G is less than or equal to 10 gumballs. It did not say graph it, so we didn't graph it. Number 16, new word problem. Oh, it's a party situation. Hopefully you all have fun parties in your futures, and sometimes you have to plan and make sure there's enough for all of your guests. So this is the scenario. You can spend no more than $100 on a party you are hosting. The cost per guest is $8. Part A says write and solve an inequality that represents the number of guests you can invite to the party. And we'll do that part first. So here, Jose had 8M has got to be less than or equal to $100. Then he divided by the coefficient 8 on both sides, so M is going to be less than or equal to 12.5. Then it asks, in part B, number 16, what is the greatest number of guests that you can invite to the party? Explain your reasoning. So we have the greatest number of guests you can invite is 12. You can go on to say, well, you can't invite half a person. And kids said, well, what if it was a child, a little person? Okay, you can do that type of math in general in your head, but if this was a test question, please note they just want you to say 12 people. That's all that you can invite. You can have a little bit of leftovers, and that's good enough. Okay, last question, number 17. And it was a bit tough, so I have it written out here. You have $30 to buy baseball cards. Each pack costs $5. You need $10 left or more. Write and solve the inequality. So you started with $30, and you're going to subtract however many packs you can buy. Let's call packs P. We have to pick a variable for the number of packs because we don't know that. But each pack costs $5. So we're going to put the coefficient 5 in front of the variable P. Now when you buy a pack of baseball cards, it costs $5, and costing means it's going to subtract from the total. So thinking about this, you had $30 minus $5 times however many packs you buy. If it would be $5 would be 1 pack, 2 packs would be minus $10, 3 packs would be minus 15, 4 packs would be minus 20, 5 packs would be minus 25, and so forth. But it says you need $10 left or more. Maybe you were planning on going someplace or doing something fun, so you need to have at least $10 left. Okay, so this amount has got to be greater than or equal to 10. If you only bought, a little bit, like 1 pack of cards, this would be still 25, because 1 times 5 is 5, and 30 minus 5 would only be 25, so that would be just fine. You could have $25 left. That would be okay by just buying 1 pack of baseball cards. But what if you wanted to do more than that? So let's solve the problem. We're going to draw our line down the inequality sign. Always we're going to undo the addition and subtraction first. In this case, it's the 30. The 30 has no sign, so it's a positive 30. Remember, we think about things like terms. It's a positive term of 30. So we're going to subtract 30 on both sides. Next, 10 minus 30. This is going to be different, subtract bigger. This is a positive term. This is a negative term. So you're going to end up with negative 20. The team that has the most players on it is the negatives, so the negative is the sign that brings down. It's the bigger absolute value number. Okay, and now we have to remember this whole thing. Negative 5p is greater than or equal to 20. Okay, so now it's time for us to divide by negative 5. And yeah, that's where the twist happens. Remember, when you have so much negativity around, when you're multiplying and dividing, the sign inverts. So here we have P, but the sign's going to flip around, so it's going to be is less than or equal to, and 20 divided by 5 is 4. 2 negatives means a positive 4. Positive 4. So final answer here is you can buy 4 packs. You could buy less than 4 packs. P could be 3 packs, 2 packs, 1 pack. You could buy 0 packs. That would be okay. But the most that you could buy is 4 packs, so that you would still have $10 left. And so that's what you would write. 4 packs. I could buy at most 4 packs of cards. Period at the end. Remember, we use correct grammar and punctuation. You start with a capital letter, end with a period, always. And that's it. Thank you so much.